Thank you, Florian, for being here. Whenever we talk about cars, it's just one of the most interesting topics that there is for us. And so really grateful for you to carve out an hour of your time to share your experiences and insights and so forth. For everyone that's joining, Florian has a really interesting background. Spent 6 years, the early 6 years of Tesla, building out their software delivery and update program. And just imagine what is it like, how would you deliver, I don't even know how big these packages are, to like a million cars over cellular networks or whatever it is. So we're going to talk all about that. Let's get into today's topic, which is all about cars. And I'm going to maybe just quickly set the stage a little bit on why we're talking about cars. And this is a slightly chat GPT generated slide, but it just kind of like, I wanted to convey, and I showed this to you yesterday, Florian, like you didn't throw up on this too bad, but like cars are hyper connected devices, right? I just learned about V2X, V2 everything. There's V2 traffic light, V2 pedestrian vehicle to other vehicle. There's all kinds of stuff. CarPlay, right? Telematics, your environmental controls and all this stuff. There's boatloads of software in cars these days, and this is turning into some pretty heavy duty breaches out there. All right. And this is some research that Sam Curry did a couple of years ago. Really incredible. If you haven't read it, if you're interested, go look him up. He did all kinds of stuff, mostly through mobile apps of cars, right? Hacking their APIs to lock and unlock car doors, start engines, locate where they are, take over accounts. Really remarkable stuff. And I wanted to share this quote from Darren Shulkusky from Ford, who spoke at our AppySecCon Automotive, where he said, these hacks by Sam Curry highlight and identify APIs as the soft underbelly of the automotive connected ecosystem. And I think this dude knows what he's talking about. He's Mr. API at Ford. So that's the setup here. Let me stop talking and remove the slides here. And first of all, Florian, maybe just give us a little bit of your background and kind of what you've been up to.
Yeah, absolutely. Thanks, Dan. So I'm in the automotive industry for about 20 years. I've spent the first third of that in what you call today the traditional automotive world, where I was responsible for the release of software and system integration of electric power steering systems. So as you can imagine, highly safety critical, because if your steering system wants to go left while you want to go straight, it's not a good idea. Yeah. So I did that for about 8 years, and then I moved, as you call it earlier, the early Tesla days. In 2012, I joined Tesla. Was a very small company, about 2,000 employees worldwide. We had one office. Everybody was in that office, from Elon Musk down to the intern, all in the same office. And I was building up a team responsible for vehicle level software integration and functional validation and release of that, including all the over the air and so on communication. Down the road, I was also responsible for a lot of things that came up, like supercharger network, home charger network, power walls. We started with solar integration until this got big enough that it started to become their own team. And I was also responsible for all the hardware in a loop test systems that ran at Tesla. So we built hundreds of those as well. I was there from the first Model S all the way to the mass production of Model 3. Then I spent a year at NIO, and then for the last third of my career, or the current third of my career, I'm a consultant under the label of iProcess Consulting, and I'm helping a little bit to facilitate the communication and understanding between those two worlds, the traditional world and the cutting edge world, if you will, because both have their pros and cons and can learn a lot from each other. So I help, in simple words, I help the established car makers to think and become a little more like Tesla, while I also help the startups and Silicon Valley companies to understand how to scale and how to build things according to requirements for regulations and stuff like that. So that is in a nutshell. I also wanted to say, I saw somebody say hello from Las Vegas. I'm in Las Vegas as well. So hello, fellow Las Vegan. And yes, that's how we are called.
Is that right? You guys are vegans? Not really.
We are not. We're just called that way. I'm sure there's a lot of steak getting consumed in
Yeah.
Las Vegas. Um,
Yeah.
yeah. So that's a little bit of my background. And speaking of background, so this is not Super Mario Bros. This is actually Gianna Sisters for people who heard about that Commodore 64 times.
Oh my.
And only coincidentally looks exactly like Super Mario, but it has a girl instead of a plumber. It's a teaser. When we get later during this hour, we get to talk about open source and the interesting challenges that come with open source once it gets implemented more and more in automotive. And we get to that. But I think then, if I may, let me just dive in right away. You talked about V2X.
Yeah, what is
vehicle
that?
to
Help us
everything.
understand. Yeah.
So there's a couple of different things, and cars start to talk to each other first within the same brand. I mean, Teslas talk to each other through a server network. We call it CV2V, so cellular vehicle to vehicle.
Hold on a second. Literally, like driving down the road, they're communicating with each other, or more like at a.
It's more about traffic information at that point, and
Okay.
similar to like Waze or something like this. But it becomes more and more route optimization and so on. It's not really that they influence the way they are driving. They're more influencing the information that goes to the driver for now. But there's more to come. And this is all in the pipeline. This is all not future. This is current development. So vehicle to infrastructure, you mentioned traffic lights. It's so interesting. I have a friend who runs a company called Light, LYT. It's a startup that helps, emergency vehicles to get a green wave when they have to go fast through a big city. And I met him at a conference in Austin. I said, but you have to retrofit all those traffic lights. It's kind of crazy. And he said, no, you know what? In Las Vegas, where you live, 90+%, give or take, already have Wi-Fi in the traffic lights. So all the traffic lights are online for traffic control. And I said, wow, okay, I didn't know that. So this is imminent. Traffic information actually going into your vehicle, not only visual, because that's how humans work, but also digital communication. That obviously opens a flurry of threat opportunities for malicious attackers, right? So from the simple things, it's like putting all traffic lights to red. That's annoying. But putting all traffic lights to green, that's dangerous, right?
Yeah.
I mean, for sure, Hollywood picked that up before, but you know where this is going. So it's going to be very interesting, and it has to be secured. The tricky part is APIs, obviously. So you can secure your product, but if I'm the attacker, I take the least resistance path. And if that's the traffic light, I'm going through the traffic light. I'm not even trying to crack your Mercedes or your Ford security.
Well, yeah, I mean, that means you got to hack every different model vehicle and so forth. And you're reminding me of a few things. I drive an e-tron. I got it a couple of years ago, and I got in it, and it said, red light in 30 seconds or something like that. I was like, how the heck does it know that? And I had no idea. Traffic lights are actually internet connected these days. It's really
I think
incredible.
in your case, it's probably still bound on high resolution maps together with a camera looking at the light. But exactly what you're saying is going to happen very soon, because if you know the light in front of you is going to turn green in 15 seconds, you're probably much more likely to coast toward the light instead of going to a full stop and so on. So there's a lot of upside to that, but obviously there's also a lot of work to secure all those things. And this is just one example. Another example that is also not new is like the environmental hacking, however you want to call it. Don't even go, it's funny that only in Hollywood movies, a hacker sits at the keyboard and is doing this all the time, then presses enter and boom, something explodes, right? This is not really happening in the real world. But simple things is like take a piece of duct tape, make a 30-mile sign, a 30-mile-an-hour sign, an 80-mile-an-hour sign. So it's a completely different interface, right? It's not a communication interface in the traditional API way, but it is an interface from the environment into the car. And the car also has to have algorithms in the software to understand that. It's like, okay, based on all the information I have, this cannot be an 80-mile-an-hour zone because I'm in a residential area, etc., etc.
Well, do the signs need to have like QR codes or some sort of like
There's
key or
actually,
something?
yes, there's stuff like this going on to store information that is more machine readable in a sign, but it still keep it human readable.
Yeah.
Um, QR code is probably a little tricky on the distance, but there are approaches for that, especially because this is powerless, right? Everything that you do powered by the car's visual system, you don't have
Right.
to put power into the sign, and it would be huge effort to put electrical power into all traffic signs we have out there.
Yeah.
And the big challenge you have here is actually fairly similar to autonomous driving. If we would purge all vehicles off the road and put only autonomous cars, we would be there right now, right? But we have a transition period, and that is long. So it's
Yeah.
the same thing as like if I put interface information into a sign, but only one out of 1,000, I have this transition period. That makes it
Right.
very, very tricky, but it has to be considered because it is not it's not avoidable. It's going to happen.
That we will move to a fully autonomous
Uh,
driver network.
in certain areas, that's for sure. But I was more referring to like the traffic signs and so on. Things like infrastructure take a lot of time to get updated,
Yeah.
and therefore
Yeah.
we will not see that happening overnight. And
Yeah.
therefore, the systems we design today have to be able to handle both.
Yeah. Yeah. No. Well, I want to. We were talking last night about like the sort of just the general like architecture of vehicles, right? And Darren Schulkusko, I mentioned, he sort of gets, I think, a little bit annoyed when people say cars are just software on wheels. It's not, right? I mean, it's a boatload of software in there, but it's different, right? Like my iPad can't crash and I die in the process, right? Like there are different, different sort of sets of risks involved here. But I always wonder, like in my vehicle, right? I've got drive-by wire. I don't think my gas pedal or my electric pedal, I guess, is physically connected to it, or my brakes or anything like that, right? And then I got my CarPlay for streaming music and all these things. Like, is it like one Uber integrated software, or is there like zones or some segregation of duties?
Yeah, for sure. So for your information, your accelerator pedal, that's how we call it these days. So
Yeah,
we changed that because no gas, so we call an A and B pedal, accelerator and brake, and
yeah,
C
and
if you have a clutch, but you don't.
I
Um,
I love stick shifts personally. I'm sort of sad
yeah,
that they're all
I got
going
I
away.
got two of them,
Oh,
but not electric. No, so going back to the to the original question. So originally, car architectures followed a distributed approach. So you had different ECUs with software and hardware separated for different features or tasks in the car. And there you have safety critical, highly safety critical, and not safety critical. And we use, it's called an automotive safety integrity level, ASIL rating. It's going from QM, which stands for quality measured, means it's not safety critical, over A to D. And basically, I never seen A or C, so it's basically only B and D. B means you are safety critical. If you do something wrong, somebody gets hurt, give or take, in a simplified way. D means if you do something wrong as a software or hardware, somebody gets killed. That's
oh
in
wow.
a very simplified way. And so you have those different systems. So your CarPlay is a QM system. So there's much more freedom for the developers and less stringent restrictions. Your driver information display, for example, is rated B because it provides you information about your safety critical systems, but it's not imminently or immediately safety critical.
Yeah.
And then your steering, for example, or your accelerator pedal, if you floor the pedal, if the pedal floors itself and you don't want that, then you have what we call unintended acceleration, and that is highly critical, and it might likely have the danger of killing somebody. By the way, accelerator pedals are by wire for over 30 years. Bosch started e-gas in the late 1980s, and they are
With
running like
no
this.
backup, no like.
It's software backup and electrical backup, but there's no cable. It's
Wow.
interesting when they call it by wire, but there's no actual wire. It's like an electrical signal that goes in and out. And there's software concept, how to secure that, but not urgently against, malicious attacks. It's more against malfunction.
Yeah.
And this is how we originally separated safety from not safety in the car. And it worked pretty well, but we are going now into what we call zonal architectures, where we have several different functionalities sharing hardware for a variety of reasons. First reason is the hardware is getting more powerful, so you don't have to spread it all out. Second is we want to actually have features delivered rather than functionality. So features are the collaboration of different functions, and they come to you as a user. And then what we see is that we have a shared hardware with different softwares. And there it's getting very complicated initially, because they might be safety and not safety critical in the same software chip, if you will. So they're sharing a flat, right?
Right.
And there are different approaches to that. One of these magic words here is middleware. So we have like a very safety focused low-level software. And we have a middleware layer that allows then applications to go on top. And depending on the safety criticality, they get or do not get access to certain resources and priorities. We could talk about that for hours, but this is basically how it's happening. There's talks in the industry to go to a central computing platform in cars. That would go further towards the iPad on wheels. But I agree with the statement that is, and I think everybody in the industry agrees that it's not the same because of the safety criticality. But when or if we are going to central compute power, we are actually looking into different approaches how to secure that. Simple things like multi-core architectures is just one of those, right? So you have safety critical cores with priority in the processor. You have non-safety critical cores which are completely decoupled from those. All those things it's in discussion and development right now.
Well, let's dissect that a little bit further, right?
Yes.
So super interesting, the ABCD, and it looks like Yelena has posted here functional.
Let me 26262 is the standard, the ISO 26262.
Is
Functional
that
safety in automotive.
okay?
There's
Cool.
also ISO 61508, which deals with the same thing, but for non-automotive, so for power plants and this kind of stuff. So if you're not in automotive, but you're interested in this approach, they use a little different. They have SIL levels, not ASIL levels, and go from 1 to 3 instead of A to D. And there are guidelines, and they are required actually in automotive to follow those guidelines for safety critical products.
So like you probably remember, like this was, I don't know, quite some time ago now, 15 years ago maybe, that Jeep that got hacked and they could slam the brakes on the freeway or something like that.
I think it's only 10 years ago, but time flies.
Really? Well, it must have been somehow like network connected, right? So like when I think about, like it's one thing for me to be able to unlock the car, right? Or to turn on the air conditioner or something like that remotely, right? So clearly that onboard feature is exposed to the internet. So like there's some like remote accessibility to it. But like accelerator pedal, is there like some sort of wall around it or some sort of segregation? So like it's not even physically or networkly accessible to the outside world?
So let me use that picturesque way you said it. So there's a wall around the accelerator pedal, but there's a door in that wall, and that's called cruise control. So the accelerator pedal itself is not online, if you will, or can be attacked.
There's no API for 70%.
It's a direct connection from the pedal to the controller that controls the motor torque and the motor speed. But there's other inputs to that. As I said, cruise control is one of them. The other direction, acceleration is one thing. Deceleration can be the same critical. Automatic emergency braking. So that's an interface that has to be highly secured, because if somebody, just imagine you get wireless access to a car on the freeway and you send an emergency braking request. That means the car will slam the brakes with full power. That gives you about a G, so almost 10 meters per second square deceleration. It's guaranteed that you get rear-ended. There's no question about it. That's a single attack, so that's scary, but it's not a larger problem now. But now all those cars get connected. Now, this is what we call swarm attacks, right? So if I'm not sending out one emergency brake request, but I send out an emergency brake request to all Ford F-150s out in California at the same time, you can imagine where that is going. So that's why those interfaces have to be highly secured against those false inputs. But the things was like door locks and so on, those are all what we call comfort features, and they are more on the QM level. They are not highly safety critical or safety critical. Sure, we talked about that yesterday briefly. Of course, there are situations where not unlocking the door can be safety critical, but in general, this is considered a non-safety critical functions.
Right.
And it's one thing to explore APIs that are already open for people using their phone app to precondition their car or something like that.
Yeah.
So you just hack the interface on the phone and you just send a command, and the car is already assuming it's correct because it comes through the correct channel. The other thing is if you're hacking onboard systems and you start from the inside of the car to spread wrong information within the car. That's actually what happened during the Jeep hacks. So they went into the OnStar system, which is their emergency call system, and they started to flash new software onto the vehicle gateway that allowed them actually to send out all that information.
Yeah.
I think the most hilarious on that was that they got hacked over the air, but Jeep could not fix it over the air. So they had to send out like 1 million USBs to all the Jeep owners to update the gateway to secure it. And that, I think that was the most interesting and in-your-face kind of situation that the automotive industry is not ready for that yet.
Well, it's something we talked about yesterday as well is like, while cars are software on wheels or whatever you want to call it, in general, like our classic car makers, Audi, Volkswagen, Ford, GM, right? They're not historically software companies, right? And so, but now they have to be, right? There's this like rapid transition. And then you have new companies that are I would say like software native, right? Rivian, Tesla, Polestar, right? Their first employees were probably coders, right? Not
Well, their CEOs are coders.
Yeah, exactly, right? And so, it seemed like that creates its own set of challenges, right? And by the way, for everyone posting questions, we're going to get to them. No question, keep them coming.
So there's actually it's a wide variety of challenges. The whole software thing, yes. When I go into an established car maker and they ask me what's the biggest change we can do to get immediate change, I say, sorry, sir, you have to fire your CEO and put a software developer on top of the company. Obviously, that's not going to happen. But the thinking of a software developer is much different. You can recompile code after you found the problem. You cannot recompile a press in the factory that easy, or recompile a piece of hardware. Yet, at least. And this is one thing. The other thing is there's also not only that they are mostly mechanical background companies, they're also 100 years old. So that means they have 100 years of tradition, processes, and things they do the way they do, because this is the way they do things.
Well, you were saying that in your car, right? You have a 12-year-old car, the same brand as your 1-year-old car, and it has the same turn signal. It has the same, lock button.
There was a locking software. I only have the newer one. A friend of mine has the older one. But it turned out that the software that runs in the lock and unlock, and I'm complaining on a daily basis to my wife about, he has the same software with the same issues in his 12-year-old car, which then shows me the software thinking approach has not arrived yet. It's a module they take off the shelf and put into their cars. And it's like, oh, we're building this fresh new SDV-like vehicle. Let's just take the 12-year-old software for the locking system. That will kind of work anyway. And this of course, those companies you mentioned, like Lucid, Rivian, all those Chinese car makers, they have what we call a greenfield approach. So they don't have to deal with legacy, which is pros and cons. Interesting thing is what we did at Tesla, most of the stuff, we didn't do it because we said like, oh, we have a greenfield approach, let's just do it this way. No, we said like, oh crap, we don't have anything, so we have to build it ourselves. And this is why we then sat down and said like, okay, we start from scratch. How do we do it? Let's forget everything about cars except of the safety aspect. And that's why people like I joined Tesla, to keep the cars safe, while all those like Silicon Valley geeks make those cars fun. Let's build the stuff the way we would do it. Let's build it with large flash memory so we can do stuff in the future. Let's build it with large touchscreens. They originally tried to source it from suppliers, and the supplier said you cannot put a 19-inch touchscreen in a car, period. And you only say that to Tesla once, and then they say, okay, then we do it, done, right? But the point is, it was not that we started and did that proactively. We did that reactively, because a lot of suppliers just didn't want to supply us at all because we're too small, or didn't want to supply us with that cutting edge approach we had. So we had to actually go over a couple of things ourselves. And that is leading to what today is called vertical integration. But it is not that we wanted to integrate vertically, we just had to, and then learned down the way that it was the right way to run the company.
Well, it's interesting just comparing. I have an Audi electric vehicle that has no software updates since the day I bought it. Zero software updates.
Same here at BMW.
Whereas a Tesla, what's the frequency of a software update on a Tesla?
So we did about 150 updates per year. Obviously, they did not go to every company, every car.
Sure.
So the frequency we agreed on in the end, because we also realized that the car owners don't want to have updates every day or every week. They feel a fatigue. So it's 6 weeks for advanced. So you can set that in your Tesla. 6 weeks for advanced, 12 weeks for standard. So every quarter, if you're not eager to try out every taste, and every 6 weeks, if you're eager to. Also depends a little bit. If you have a newer platform, you probably get more updates because they're ironing out a couple of like user experience things.
Sure. No, but
even in 12-year-old car, every 12 weeks.
It demonstrates the difference between legacy car makers and new. But I want to make sure we're halfway through here, so I want to get to some of these questions because they're really cool. So let's throw a few of these up here. So this one from Faisal. As we all know, that self-driving car is booming, especially Tesla. There's a lot of AI already in use in computer vision to voice, AI assistance to traffic and lane navigation. All this not possible without APIs. There is no AI without APIs. What strategies do automakers use to secure AI-driven APIs? This is really interesting. It's a whole, like, we're adding another layer of complexity on top of this.
I wish there would be a really nice and clear answer to that. I think currently automakers are trying to understand that, what you just said. And they have small teams starting to work towards that. But it is not really a broad, clear strategy because from all I understand is they don't really grasp the whole problem as such yet. Automotive is usually about 10 years behind IT. So we're really in the very, very, very early stages. There are some AI topics in there. And yes, for sure, there are vulnerable APIs in there. So we haven't seen the big attack yet. That's why the whole topic is like, just boiling a little bit. It's not on fire yet. But I'm afraid there is no comprehensive strategy the automotive industry has as of now.
Yeah, and I think AI is a wild west, right? And it's one thing for Travelocity or Dropbox or something to embrace these new technology, but cars, there's a level of risk that makes them have to take more time and be more secure. Let's answer a few more of these. So here from Mohammed. How do over-the-air updates ensure security against supply chain attacks and rollback vulnerabilities in multi-core architectures?
Yeah, that's a complex question. I hope I understand it right. So we had at Tesla, we had this problem, especially with the rollback, that you fix a vulnerability and the user actually just rolls back to a non-secure version and keeps the vulnerability open. So we implemented what we call a ratchet system, so that there's only one direction you can update. So only in R&D we were able actually to update to a lower software version. In production cars, you only can update forward, and that's secured by a key. So you cannot modify an old version to look like a new version because then the checksum and the key wouldn't fit.
Yeah, interesting. Let's enter this one from Ibrahim. Given the increasing complexity
Guys,
of,
keep the questions shorter.
I know. Well, there's people have really fascinating questions. So this is your area, SDV, right?
Call it
Given,
ratchet system. Sorry, I just saw the question. Ratchet system.
oh, is that a different question?
It was just like, what did he call that again? I just wanted to answer that real quick before it moves out of the window. Sorry. Go ahead.
Yeah, no. So given the increasing complexity of SDVs and reliance on APIs, what are most critical cybersecurity challenges that automotive manufacturers need to address to ensure safety and security of these vehicles? And how can they mitigate them in real life? This is a pretty broad question, right? But
Yes. The first question, the first answer is like, bring your technology into the 21st century, because 98% of the cars out there running a CAN bus system for communication between components, which is designed in the 1980s and has nothing about security in mind. And it's plain straight hex information, and you can reverse engineer it within minutes. So as soon as you get access to the car, you can easily, compromise all the communication in the car. So that's the first thing they have to do. They have to secure their internal car communication by using automotive Ethernet is one of the things that comes broader into it, but also just like encrypt the communication within the car, which is a low-hanging fruit, but it's shockingly open. If you buy a device for $10 on eBay, you can basically read everything that's going on in your car.
it's not unusual, right? These, like, I remember seeing 20 years ago at a cybersecurity conference, somebody hack their own insulin pump, right? And the insulin pump had a wireless connection, and it was 100% unencrypted. There wasn't even any like authentication involved, right? And it's because 20 years ago, like, no one thought about like someone's going to try to hack this thing, right?
Correct.
And so that first generation is always kind of just loose and insecure, and then next thing you know, right, that technology sticks around for 20 years.
Yeah, and I mean, the general connectivity between all the components and things we are using actually brings that risk, right? So, in general, also in the automotive industry, to actively hack a car that's in front of you doesn't count as a malicious attack as such, as a vulnerability, because the car makers say, look, if you have physical access to the car, you can also just cut the brake lines or slice the tires.
Sure.
So, but as soon as the vehicle is getting connected, and you have those that what we called earlier swarm attacks, that actually presents a risk that hasn't been there actually until the emergence of at least LTE, I would say even 5G, because the communication was just not so sophisticated.
Yeah, super interesting. How about this one from Anders? Is there any difference between gas and EV car security? Or are there any nuances that
I mean,
people
the
should?
short answer is no. But of course, the EVs are usually with a much more modern architecture, which makes them more vulnerable right now, because combustion cars usually run more older technology, and that gives them a little bit of a little bit of a safeguard. But in general, if you would design an ICE car, so internal combustion engine car, from scratch today, and an EV car from scratch with the same approach, there's no difference. The little bit of a bigger threat you have is that EVs have like immense amount of torque. So if you manage to actually hack their propulsion system, you can actually accelerate them much faster. This is just based on the
Right.
powertrain approach. But in general, from a security point of view, there's no big difference.
It's remarkable. My e-tron is 6,000 pounds and accelerates faster than a 911 turbo from 30 years ago. It's kind of
Yes.
it's crazy. How about this? We haven't talked about regulations here, and Hussein is bringing up NIST, and I know
Yeah.
there's like UN regulations,
Yeah.
there's ISO regulation. I was really shocked to hear like the UN regulation is adopted by virtually every country, but not the United States.
Yeah.
So maybe just comment a little bit about like where the regulators are coming in.
Yes, and we always have to be making a difference between regulations and guidelines. So some of those things are guidelines, and some of those are not. So UN ECE released Addendum 155, which is dealing with cybersecurity updates or vulnerability fixes. and the member countries, which is basically EU plus US, and so the EU part of it made that mandatory. And a lot of people don't really know that yet, but starting 2022, so 3 years ago, it was mandatory to secure and follow a cybersecurity management system in all new vehicles coming to market in the European Union. Starting 2024, it became mandatory for all vehicles coming to market, so not only new ones. And I brought it up yesterday, Dan, really quick, that is the reason why Porsche took the Macan off the market, their most successful vehicle. It is gone from the market because they say it is not worthwhile to add the cybersecurity management system because we have a new vehicle coming out in 2025. It actually just came out this week. Wow. It looks great. And it's all electric. And that has a broad impact. There's also cars disappearing from the market. The Land Rover Defender. It's an issue with security and safety, actually, as well in this case.
Wow.
Lada doesn't sell Nivas in Europe anymore because they're not secure. So there's other reasons for that. So R155 only requires a cybersecurity management system. Now the industry is there, is like, where are we getting that from? And then ISO comes around, it's like, hey, we have the 21434, and I saw that in the comments earlier. Cybersecurity in automotive. Hey, that's handy. Let's use that. But I want to be very clear. ISO 21434 is not mandatory. R155 is mandatory in the US, and it requires cybersecurity management system. ISO 21434 offers a guideline to build one, so the vast majority is using that. There's also ASPICE for cybersecurity. There's other standards that are going in that direction. Also, and I just going back real quick with the ISO 26262, because it's the same with the 21434. Those are not required for type approval and to get your car on the market. Those are required usually by OEMs, so by car makers, to assess their suppliers. Example of Tesla, for example, Tesla is the OEM, so they don't have to follow any of those standards in order to get the car approved to get a type approval for the markets.
It's really remarkable what you're saying about these the UN regulations. It's a mandatory regulation, and it's causing car makers to remove vehicles from their lineup or even exit whole markets. Just astounding. What was the year? What year is it managed? Because maybe I'm not going to buy anything until that.
Last year. No, it's last year. But only in EU. So if you buy a car that is not available in the EU, it's probably not following those standards or requirements.
Right. No, that's something to think about here. Let's go to another one from Chandu. Since SDVs are connected to be a boarded network of cars, can hacking into a car can that be used? So can we hack another car from one exploited vehicle?
And I think this is one of the large vulnerabilities we all have to think and address. So that's when I said swarm attacks earlier, that's what I'm thinking. Because imagine you don't actually have to hack into a car. You can just buy one. And you just, work from your own car and you actually threaten out. We're going back to the environmental hacking. You don't even have to do this. Imagine, and it happened. There was once a dude who bought like 1,000 Google phones and put them onto under a bridge or something like this, and then Waze reported a gigantic traffic jam and rerouted all those cars around, right? So don't even have to go down and hack on a software level. You can actually do other kind of hack attacks too. So the answer is a clear yes. So if you talk with your own cars from your own brand, so Tesla to Tesla or Ford to Ford, that's relatively easy to figure out if that's a correct statement. But now we are going into vehicle to vehicle different brands. So as a Jeep, do I trust that Toyota? Do I trust that Honda? Do I trust that Ford? Do I trust a Ford more than I trust another brand? That's all stuff that's happening as we talk. It's not that it has been figured out yet.
So in this future architecture, this future world of vehicle to everything, is it inevitable that vehicles are going to communicate with each other? Like I'm going to be turning left, or I'm going to pass you on the right, or whatever. Like are vehicle to vehicle communications like an inevitability?
In the long run, I mean, currently we have that, right, in a visual base. So you put a turn indicator. At least you're supposed to put a turn indicator when you want to turn, and this is left to the drivers to enforce that or to execute that.
Sure.
From that point of view, it will get better actually, because cars will not just be lazy and not do the turn indicator because they don't feel like it.
Yeah.
They will always indicate that it will take a turn. But we have, as I mentioned earlier, we have this transition period, and that's many years. I don't know,
Right.
30 years from now on or something like this. And then once we are going into a majority of autonomous transportation, and I'm not saying everything will be autonomous. There will be, like, for the fun, don't worry, you get your stick shifter race car, you can keep that. But the standard commute going downtown, whatever, that's probably going to be autonomous in the mid to long run. And those vehicles will actually take the advantage of communicating with each other for a variety of reasons: route optimization, safety, but also maybe you want to communicate, with somebody else in another car, and all this kind of stuff. So yes, that is going to be the case.
And I think Jose, I'll throw this question from Jose. It just came up, and it kind of reminds me of, like, there was a guy in London who registered a company, and the name of his company was a SQL injection string, and it got registered with the UK authority, whatever, and it turns out their own servers were vulnerable to this string, and anybody who queried that site would get a SQL injection attack. Now, fortunately, he made it kind of funny, but, like, if you have a model of vehicle that's not well designed, and another vehicle, if you hack your own vehicle to send a SQL injection request or some other malicious request, like, this vehicle to vehicle security is quite crucial.
Absolutely. I mean, just imagine what you have, and you just put that into your car, into somebody's car, and it's just driving down the highway, and it's just like whoever is in Wi-Fi range or something like that, you just get like that sent over. This in general it's a huge challenge, and I'd like to get back to my background real quick before we
I
forget
forgot
that.
about your
Right?
background. Yes.
Yes. So this is about open source, but it's not only about open source. What you say, it's also like talking to other owners of other software, right? It doesn't matter if it's open source or closed source. So it turns out at Tesla, we used an open source library for the media player, and they actually found something, and they tested it out. And so if you take a MIDI file, for the older in the call, they know what a MIDI file is, and that MIDI file plays something like this, right? So that reminds a lot of people in their childhood. Then it opened a backdoor in that open source code, which you can then use to access the vehicle network. I don't want to go into much more detail how and what they did there, but just this, and in this case, it was like a joke, right? So somebody programmed that in there as a joke, but as soon as that finds the way into a car, it's not a joke anymore, because it can become safety critical. And it's the same thing also when you deal with other car makers. So you have to hold everybody on the street to a certain standard. So it doesn't matter if you have like the ultra secure tank of a car, but everybody around you doesn't hold up your standards and is sending you false information and is creating issues in your car. So it's an interesting thing. We have to work together on that.
Yeah, and what you opened up with is, it's not even just the vehicles. Like, we've spent a lot of time talking about, like, security inside the vehicle, right? Like, the software that governs how the vehicle performs and what it's doing and all that. But you pointed out, like, all you got to do is hack the traffic light, and you can cause serious harm, major chaos. And there's an example, slightly different, but I think it was Yandex in Russia. Someone hacked, I think it was activists, hacked the Yandex app. This is their, like, Uber ride sharing thing, and they sent like 1,000 vehicles to the same location, right, in front of Hotel Ukraine, on their major thoroughfare of downtown Moscow. And there you go, right? Chaos right there. Like, and that was just from not even a car, not a traffic infrastructure. It was from a mobile, car, taxi app that they were able to do this.
Yeah, so the challenge you have with malicious attacks is that they are basically infinite options, right? So you can do a lot of things. I saw earlier somebody talking about threat analysis. Yes, that's what we're doing, right? So we do threat analysis, but that is limited by our knowledge and fantasy at one point. And sometimes some people come up with much more weird ideas. As I said, I don't even know how they found that thing with the Nintendo tune, because wasn't on my list of testing in the first day, right? So somehow they must have found some hint over there. But that is actually why it's so important to monitor and react. It's impossible to foresee every possible malicious attack. You can do a lot, and you should, but
Right.
not everything. So you have to monitor. There are now actually tools and systems in our future, in our cars, so in development. They will come in our future vehicles that are monitoring suspicious behavior within the car, and then they start and they trigger sort of actions. Everything from like information to the headquarters to blocking information, or even at one point maybe blocking the car from going online or something like that. So this
Right.
is happening, and it has to happen, because it is impossible, even with AI, it's impossible to foresee every
Well,
malicious attack. And one thing I love to tell to all my traditional car clients is like, hey, the malicious attacker will not agree to requirements freeze or design freeze or code freeze. If you say my car is secure today, that might totally not be the case tomorrow. So you have to focus on, keep an eye on your product while it's out there. Going back to the UNECE norm, that actually requires 15 years of updates of vulnerability fixes after the end of production. The average production runtime is somewhere 8 to 10 years. So you talk about 25 years of software updates. Now we have 2025. Anybody who is still working on Windows Millennium, which was yay.
that's remarkable. That's really remarkable. Well, we haven't even talked about autonomous vehicles. I think there was Neil deGrasse Tyson made a comment. I don't know if this is true or fake, but the comment resonated with me, which was, there was the clickbait, comment, which was autonomous vehicles will kill people. And then the rest of the comment was, but over time, like every time there's a failure, they're going to learn, and then all million vehicles will get that update, right?
Correct.
And over time, there's no doubt that these will be far safer than non-autonomous vehicles. And I have a 16-year-old who I'm teaching how to drive. And the other day we got to a red light and I said, "Oh, well, you're allowed to turn right on red." So he just started going. And I was like, "Whoa, you gotta still look, right?" But
Can
there are a
you
million
talk to half of
16
the
year
people here in Las Vegas and tell them that as well?
Oh, all right. Well, there you go.
Yeah.
But to your point, like there's this continuous learning, and the more miles, the more hours, right, the better it gets.
And this is a very interesting and important point. Humans get the permission to operate up to 16 ton of a vehicle after passing a half-hour exam at the DMV with a lady who or a sir who is
Yep.
maybe not even much interested, right?
Right.
And then we in no way assume that a 16-year-old going out with a like an RV or whatever knows everything about this world, right?
Yeah.
So, but they learn
Right.
over time. So the same thing happens with SDVs and autonomous vehicles, but the difference is they don't have to learn by themselves. They have shared learning.
Yeah.
So I always say, like, hey, if I go to Australia and I see a wombat, which I've never seen a wombat before, but I would assume it's probably something I will not drive over, but around, right? And imagine now I drive around that wombat, I take a picture and I send it to everybody I know and say, from here on, don't drive over those wombats, drive around them, right?
Yeah.
And this is exactly what's happening with the autonomous vehicles, and even before, also with the partly autonomous vehicles or assisted driving. They see something, they learn, and that learning might cause an issue in the first encounter, but then they share that information. That brings us back to the original topic, of course. If you figure out a way to share malicious information, that's also something that has to be considered. That, if I call around and say, hey, if you see this kind of wombat thing, drive over, it's hella fun, right? So, or what you
Well,
say was the red light. If you share information, it's like, hey, don't stop at red lights, just go
yeah.
over it from now on, right? So that's obviously a problem too.
So we're gonna wrap here in just a sec, but like maybe
Yeah.
the last question is like what is the motivation here, right? Like we haven't talked about like I understand hacking banks, right? Like there's money, there's is there an incentive
So
I
there's
mean, obviously hacktivism and terrorism, I get that, right? But most people aren't in that business, right? Like for a common hacker, is there an incentive here?
So I would say there's like probably it's three different tiers of hackers. One is the one who does it for glory, right? And we worked at Tesla. We worked with those people. We gave them money when we had a bug bounty, which I think is a great approach. If you report a vulnerability to Tesla, you
Sure.
get $10,000. But the requirement is you are not going public with that vulnerability until it is fixed. So
Sure.
those are the hackers. They want to go on their hackathons or whatever. They want to show off, and they go out and say, "I hacked a Tesla," but don't worry about it. It's already fixed because I reported it and they fixed it over the air, and you cannot do that hack anymore. And they get 10 grand for it. Those are ones for glory. You have the ones for ransom. That happened actually just here in Vegas last year with the hotels. They got hacked and they paid like $80 million ransom. So we will see that on cars as well. And I'm sure we have seen that already, just not in public, because nobody wants to publish that information. But
Yeah.
that, and then of course the terroristic background, we don't have to talk about that, but it's obviously
Sure.
another risk.
Well, with that, I want to thank you, Florian. We could go for another 2 hours. So maybe I'll bend your arm and we can do this again. For everyone that contributed, this was really super fantastic session. I apologize we couldn't get through all the questions, but we'll try to follow up with each of you. What Christina's just shared here is Florian and I are collaborating on what we're calling an automotive API security workshop. So if you work at an OEM or a tier one supplier or someone in the automotive space where your organization could benefit from a private session featuring the two of us, we're pleased to do that. It's a place where you can let us know you're interested and would certainly follow up with you. No charge for that. It's free. And we just want to help spread knowledge and awareness of API risks and cybersecurity and so forth. I know, Florian, you said you're not a cybersecurity expert, but I beg to differ with that. This has been a really extremely interesting.
I'm on the system engineering level. Yes, maybe. I just wanted to say I put my LinkedIn LinkedIn page there in the comments. Find me on LinkedIn. Please connect and send me your questions. I'm happy to follow up on those. It's super interesting and
please
reach out. No worries.
I'm glad you did that. I was gonna tell everyone, follow Florian. He posts some really interesting short videos, and they're quite entertaining and extremely interesting. So definitely look him up, Florian Rohde, Rohde. I'm used to the H being before the O, so get that correct. Florian, man, this was a super fun session. I really truly enjoyed it. I appreciate you giving us your time. And yeah, man, if you're up for it, I'd love to invite you back.
Oh yeah, absolutely. I mean, I think there's so much stuff to talk about still, and I haven't even talked about all the anecdotes I wrote down here, and there were so many great questions we haven't had a chance to get to.
All right, so let's just plan on it. We'll bring you back in the near future. All right,
sounds great.
Thanks everyone, and
thanks everyone.
See you at AppySecCon or another one of our sessions. Take care, everybody.
Bye.